Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to the course Computer Oriented Statistical Methods. Today our topic is Regression Part 2. Today we are going to discuss finding the regression equation. Finding the regression equations when the means are not whole numbers. When the means are not whole numbers. That means if the means are fractions, then we consider the deviations from assumed means. We don't consider the true means, we consider the assumed means. If the actual mean is a fraction, then we consider the assumed mean, and let us denote the assumed means by capital A and capital B. These are the assumed means of x and y values respectively, and the formula to find the regression equations are given by, so there are two types of regression equations. One is the regression equation of x on y is x minus x bar x on y. So LHS is having x in terms of y, r into sigma x by sigma y, y minus y bar, and this is the regression coefficient bxy. We can rewrite this as x minus x bar is equal to bxy into y minus y bar, and that bxy is given by sigma x into sigma xy minus sigma x into sigma y by n divided by sigma y capital Y square minus sigma y whole square by n. Similarly, the regression equation of y on x is given by y minus y bar, y on x, so y on LHS, y in terms of x, so x on RHS, r into sigma y by sigma x. This is again the quotient of regression multiplied by x minus x bar, and here we have capital X and capital Y values. These are given by small x minus the assumed mean A and small y minus assumed mean. In the previous case, if the means are the actual means which are whole numbers, then we use capital X is x minus x bar and capital Y is y minus y bar. So this x bar and y bar are the original true means, whereas in this case we use the assumed means, and the main important point is we use the assumed means only to find capital X and capital Y, but in the original regression equation we have to use the true means only. You can see here x minus x bar, I am using x bar notation, and y minus y bar. So these are the original true means, but to find capital X and capital Y I am using the assumed means. Similarly, the regression equation of y on x is having y bar and x bar, and to find sigma y, r into sigma y by sigma x, which is the regression quotient, here again this can be written as y minus y bar is equal to regression quotient of y on x byx into x minus x bar, and this byx is given by this formula. If the data is given, we need to calculate these two values. Sometimes in some problems the standard deviations of x and y will be given. That means sigma x, sigma y values will be given, and the correlation coefficient r also will be given. Then to find the regression coefficient, simply we calculate this r into sigma x by sigma y. But if the data is given, the values of x and y are given, then we use this formula. Let us solve one problem. The price indices of cotton and wool are given below for 12 months of an year. 12 months of a year. Obtain the equation of lines between the indices. So that means we need to find both the regression equations. Both the regression equations, x on y as well as y on x. Now, to find the regression equations, first we need to calculate the quotient of regression, and which is denoted by bxy, the quotient of regression of x on y, or byx, the quotient of regression of y on x. To find these quotients, first we need to calculate the means of these two values. Let us denote the first one, cotton, the indices by small x and wool by small y. Let us calculate the mean values. So, mean of x values, x bar equal to sum of all these values 78 plus 77 plus so on. The last value is 93 and total number of values 12 values. So, the data is given for 12 months. So, divided by 12, which results as 83.67. Similarly, the mean of y values, y bar is 84 plus 82 plus so on, the last value 99 divided by 12, which is 88.42. And it is very clear that these two values are not whole numbers. We got as fractions, decimals, 83.67, 88.42. In this case, we need to consider the assumed means. Assumed means, how to consider the assumed means? After this decimal, if the number is greater than 5, we can consider the next value. So, let the assumed mean of x values be capital A, 83.67. So, we can take 84 as the assumed mean of x values. Similarly, here 88.42, this 4 is less than 5. So, assumed mean of y values B is 88. Now, we use these two values to find the regression coefficients bxy and byx. In the present problem, we need to find both the regression coefficients because we have to find the both regression equations x on y as well as y on x. Now, to calculate the values of bxy and byx, let us construct a table and convert the x values into capital X, y values into capital Y. Using capital X is x minus the assumed mean of x values, capital Y is small y minus assumed mean of y values. So, this is x minus 84 and this is x minus 88. So, here the first column denotes the values of x and the fourth one denotes the values of y, and we need to convert small x to capital X using this x minus a. So, here capital X is small x minus, what is the assumed mean of x values? Just now we have calculated 84. So, x minus 84 and capital Y is y minus 88 is the assumed mean of y values. So, x minus 84, 78 minus 84 minus 6, 77 minus 84 minus 7, 85 minus 84 1, 4, 3, minus 2, minus 3 and minus 7 and again here minus 8, 83 minus 84 minus 1, 97, so 13, 93, 9. So, these are the values of capital X and this is sigma capital X minus 4. Now, let us square these values and add, because in the formula we need sigma x square, sigma y square, sigma xy. So, that is why we are constructing this table to calculate the required values. So, x square, 6 square, 36, 7 square, 49, 1, 16, 9, 4, 9, 49, 64, 1, 169 and 81. And this denotes sigma x square. Similarly, we need to calculate capital Y, then capital Y square. Capital Y, y minus 88. So, minus 4, minus 6, again minus 6, minus 3, 1, 2, 0, 4, minus 5, 1, 10, 11. Let us square these values. 16, 36, 36 again, 9, 1, 4, 0, 16, 25, 100 and 121. And this gives sigma y square values and this is sigma y values. Similarly, we need sigma capital XY. That's why we multiply these corresponding values. Capital X into capital Y. Minus 6 into minus 4, 24. Minus 7 into minus 6, 42. 1 into minus 6, minus 6 and so on. And this is the total of such values. So, sigma capital XY is 287. Now, using these values, first we find the regression coefficients and then the regression equations. To find the regression coefficients Bxy and Byx, first let us write all the values sigma capital X, sigma capital X square, sigma capital Y, sigma capital Y square and sigma capital XY. So, here sigma capital X is minus 4 and capital Y is 5. Minus 4, 5 and x square is 488, y square is 365, 488 and this is 365 and sigma xy is 287. So, these are the values that we have calculated by constructing a table sigma capital X, sigma x square, y square, sigma capital XY. Now, first the regression equation of x on y. What is the regression equation of x on y? X minus x bar is equal to bxy into y minus y bar, where this bxy is calculated using the formula sigma x into y minus sigma x into sigma y by capital N divided by, you can use this formula sigma capital XY minus sigma capital X into capital Y by N and x on y. So, the denominator is having y terms. Similarly, in y on x, the denominator is having x terms. That is only the point to be noted. If you want to find the regression coefficient of x on y, denominator must contain y values only. There should not be any x value. Similarly, to find the regression coefficient of y on x, denominator must contain x values. So, the denominator is here sigma y square minus sigma y whole square by N. Sigma y square minus sigma y whole square by capital N. And here the values are given for 12 months. So, capital N is 12. So, using this formula and substituting all the values, sigma xy is 287 minus sigma x into sigma y. So, minus 20 divided by 12 whole divided by sigma y square 365 minus sigma y whole square 25 by 12. So, after simplifying this, we get 0.795 and therefore, the equation is x minus x bar. What is the original mean of x values? 83.67. That is equal to 0.795 into y minus y bar. And what is y bar? The actual mean. In the equation, we have to substitute the actual mean values. But to find regression coefficients, we use assumed means. And y bar is 88.42. So, after simplifying this, we get x equal to 0.795 y plus 13.38. This is the regression equation of x on y. That means x in terms of y. Similarly, we need to calculate the next one, the regression equation of y on x. The regression equation of y on x. Y minus y bar is equal to byx into x minus x bar. And where byx is, again use the same similar formula sigma capital XY minus sigma capital X into capital Y by N divided by Y on X. So, denominator must contain X terms. Sigma X square minus sigma X whole square by N. So, let us substitute all these values. 287 minus sigma X into sigma Y, again minus 20 divided by N is 12, and denominator sigma X square is 488 minus sigma X whole square 16 divided by 12. So, after simplifying this, we get 0.59, and therefore, the regression equation of of Y on X is Y minus Y bar. What is Y bar? The original true mean of Y values, 88.42, is equal to 0.59, the regression coefficient of Y on X, multiplied by X minus X bar, the original mean of X values, 83.67. After simplifying this, we get Y equal to 0.59x plus 39.05. So, this is the regression equation of X on Y, and this is the regression equation of Y on X. So, if the data is given, first we find the mean values of X bar and Y bar. Depending on the values of X bar and Y bar, we consider the suitable formula, and then we calculate the regression coefficients Bxy and Byx and substitute in the equation of regression. Similarly, let us discuss one more problem on the same. Calculate the expected value of Y when X equal to 12 from the following data. So, it is required to find Y. What is the value of Y when X equal to 12? What does it mean? If we have an equation Y in terms of X, simply we substitute X equal to 12 here so that we can find Y. So, that means we need to find the regression equation Y on X. So, what is the regression equation of Y on X? Regression equation of Y on X is Y minus Y bar is equal to R into, again here Y on X. So, sigma Y by sigma X, where sigma Y and sigma X are standard deviations of Y and X values, multiplied by X minus X bar. If the data is given, we need to find the regression coefficient using the previous formula. But here, directly the average values are given. The first average is 7.6, this is for X and this is for Y. Standard deviation 3.6, 2.5, and the correlation coefficient R is also given. Now, given X bar is 7.6, comma Y bar is 14.8, sigma Y is 2.5, sigma X is 3.6, and R is 0.99. So, let us substitute all these values here. Y minus Y bar is 14.8, R is 0.99 multiplied by sigma Y by sigma X. So, 2.5 by 3.6 into X minus X bar is 7.6. So, after simplifying this, we get Y equal to 0.688x plus 9.57. Now, the question is to find the value of Y when X equal to 12. So, put X equal to 12 here, that gives Y equal to 0.688 multiplied by 12 plus 9.57. and which results as 17.826. So here direct values are given, the means and standard deviations are given. So we use R into sigma y by sigma x to find the regression coefficient. And first, since it is required to find y when x equal to 12, we need to find the regression equation of y on x and then put x equal to 12. Similarly, let us discuss one more problem. From the following data, calculate the correlation coefficient and standard deviation of y. So, it is required to find the correlation coefficient. What is the value of R? And standard deviation of y, sigma y. These are the required values. What are the given values first? The correlation, regression coefficient, the regression coefficient of x on y is given, y on x is given, and standard deviation of x is given. And we have the relation between correlation coefficient and regression coefficient. Regression coefficients. What is that relation? R is equal to under root the product of regression coefficients bxy into byx. So first we calculate the correlation coefficient using this relation. So under root bxy is 0.85 multiplied by 0.89 and the answer is 0.87. So this is the correlation coefficient calculated using the relation between correlation coefficient and regression coefficients. Similarly, we need to calculate the standard deviation of y. For that, let us use the regression quotient of x on y. X on y, bxy is r into sigma x by sigma y. So we have bxy, the value is given 0.85. Just now we have calculated r 0.87. Sigma x is given 3 by sigma y is unknown. We want to calculate this value. So 0.87 multiplied by 3 by 0.85 and the answer is 3.07. So therefore sigma y is 3.07, standard deviation of y value. So we can use the relation between the correlation coefficient and regression coefficients. In this particular problem, the remaining values are given and it is required to calculate the correlation coefficient. So R is given by under root the product of regression coefficients. Since these two values are given, we can calculate using this property. Similarly, the standard deviation of y can be calculated using the quotient of regression formula. So this is for today's session and we will meet in the next session. Thank you.